Clicking through Cloud Portal menus to configure a server is tedious. One missed checkbox or mistyped IP address can compromise an entire environment. Today, we are going to bypass the interface entirely. We will use Terraform to provision a fully functional Linux virtual machine on Azure. Before we write any code, you need Terraform installed on your local machine. You also need to connect your local environment to your cloud account. Run the Azure CLI login command in your terminal to authenticate. Defining your infrastructure as code replaces ad hoc clicks with a predictable, versioned blueprint. This creates a repeatable record of your environment that is easier to audit and replicate. We start by organizing our workspace. As you can see in this editor view, our directory separates concerns into 3 specific configuration files: providers.tf, main.tf, and ssh.tf. This maps our nested architecture. A top-level resource group branches down through a virtual network, subnet, network interface, and finally the Linux VM. Inside our core configuration, we declare the virtual machine block matching that bottom node, defining its size and operating system. With the files written, we run the initialization command. Typing Terraform init prepares your local directory for the deployment. In the background, this process reaches out and downloads the Azure Provider plugin required to manage your specific resources. You will know you are ready to proceed when the terminal prints a green success message stating Terraform has been initialized. Writing the configuration and initializing the provider translates your local text files into a set of instructions the Azure API can understand. Next, we generate an execution plan. As shown in this split-screen layout, running Terraform plan acts as a dry run before any actual infrastructure is altered, listing out the planned additions. This command actively compares your local code blueprint against the current reality of your Azure environment to see exactly what needs to be added. Once you confirm the plan is accurate, run Terraform apply. This executes the blueprint and begins the physical provisioning of your resources in the cloud. This illustrates what happens next: the sudden appearance of a new file called terraform.tf state. This state file acts as the tool's memory. It tracks the newly created Azure resources, locking the relationship between your code and the cloud. Never edit this file manually. Tampering with the state file will corrupt your environment's memory and disconnect your code from your cloud resources. Managing this local state memory, rather than simply firing off execution scripts, is what turns Terraform into a powerful, declarative orchestrator. Provisioning is complete, but we cannot assume the deployment worked flawlessly. We need to actively verify the build. This terminal output shows the result of running the Azure CLI command to query active virtual machines. Our specific Linux VM identifier is present, and its status is running. Retrieving this status from the terminal is significantly faster than logging into the Azure Portal and manually navigating resource menus to check health. Using the command line to verify your build confirms that the resources active in your Azure account exactly match the specifications in your local files. You have successfully provisioned a secure, repeatable Linux server entirely via code. But if test servers are left running indefinitely, they become orphaned resources, quietly spinning up costs and creating financial risk for your organization. To completely tear down the newly built infrastructure and stop the billing clock, run the Terraform destroy command. The tool includes a built-in safety mechanism. The destruction process halts and requires an explicit manual confirmation, typing yes, before a single asset is deleted. Managing the entire resource lifecycle, from automated creation to guaranteed destruction, ensures your cloud environment remains organized and cost-efficient.